Welcome back to Starting from Scratch. Today we'll be learning about the control blocks, variables, and how to control a character using the arrow keys. We'll make a quick little game called Chase the Cat, which you can customize however you'd like. It'll look something like this. I'm moving the dog around with my arrow keys, and I'm chasing the Scratch Cat around, which moves randomly and bounces on the walls. In the corner, you can see my score, which increases whenever I catch the cat. The game just goes on forever like this. In this lesson, I'll show you how to make this basic game, and at the end, I'll challenge you and give you some ideas to add on to it. Let's get started. Okay, start with a brand new project. We'll need one sprite for the player and one sprite to chase. I'll make a sprite for our player, and I'll use an animals dot the dog. For now, I'm going to hide the Scratch Cat as we'll just be working with Dot. First of all, Dot is a little big and doesn't have that much space to run around, so I'm going to set his size to 50%, which is half of what it usually is. And I'll attach that to the when green flag is clicked block, and we'll try this out. There we go, a lot smaller, has a lot more space to run. Next, let's see how to make Dot move. In the Control tab, take a look at this if-then block. There's two spaces, a pointy block and a space for blocks to go inside. The pointy blocks are mostly found in sensing, for example, touching mouse pointer or touching color, and operators like greater than, less than, equal, and, or, not. These are all things that you can check, which we'll call conditions. In an if-then block, if the condition is true, then all the blocks inside will be run. These are called if statements, and they work just like in English. For example, if it's raining outside, then bring an umbrella. In our case, we want to make Dot move with the arrow keys. So if the up arrow is pressed, using this key press block found in sensing, then we want to move Dot. And we want to do this for all of the arrow keys, so I'll attach this and I'll duplicate this and make 4 for all of the different arrow keys. Select down, right, and left. Okay, now how do we move? If you remember from the last video, Scratch uses X and Y coordinates, which are just numbers that represent the position of your sprite on the stage. Your X position is your horizontal position, so left and right, as you can see here, and your Y position is your vertical position, so up and down, as you can see here. So to move up, we want to increase the Y position because a bigger number will be higher. So we'll go to Motion, and we'll use the Change Y block, and we'll put this in the block where it checks if the arrow key, the up arrow key, is pressed. To move down, we want to decrease the Y position, so we can change this number to -10. For right and left, we'll just use Change X instead of Y. Okay, now let's try this out. If I click the green flag, or I'll just click it up here, and then if I press my arrow keys, well, nothing is happening. Dot isn't moving. So why not? It's actually because we're missing a block. When we click the green flag, all of these blocks run once very quickly. So basically, as soon as you click the green flag, Scratch sees that you aren't pressing anything and says, well, guess we don't need to do anything, and it stops checking. But that's not what we want, because we want Scratch to always know when we press an arrow key. That's where the forever block comes in. If we surround all of these with a forever block, then it'll keep running everything inside over and over forever. So then when we try to move again, you can see that we're moving around correctly. Basically, for each arrow key, it's checking, are you pressing the arrow key? Nope. How about now? Nope. How about now? Oh, yep, let's move. Still pressing? Okay, move again. And now? Nope. Since it's doing that for all of our keys, we can move our character. We can even go diagonally if we press 2 keys at once. Also note that all of these blocks are highlighted yellow, which tells you that they're running. Before we added the forever block, it actually flashed yellow really quickly when it ran through these 4 if blocks, but it happened so fast that we could barely see it. Since a forever block happens, well, forever, we can see that this stays yellow. We also want Dot to face left or right based on if we're moving left or right, because it looks a little silly to run backwards like this. We'll use costumes for this, so go to the Costumes tab. You can see that Scratch already has 4 costumes for Dot. We can make a copy of this first one by right-clicking and clicking duplicate, and then we can make him face left by clicking flip horizontal up here. In programming in general, you want to make sure you use helpful names because it'll help you remember what is what. So instead of .a, let's do .right, and instead of .a2, let's do .left. Now let's go back to Dot's code. We'll go to the Looks tab, and we'll use the Switch Costume block. So when we're moving right, we'll want to use .right, and when we're moving left, we'll want to use .left. And let's test this out. And now we face both ways. Now there's one more change I'll make to Dot. He's really fast. So maybe changing X and Y by 10 is too much. If I want to change his speed right now, though, I'll have to change it in 4 different places for all 4 directions, which is kind of annoying, especially if I want to try a bunch of different speeds until I find one I like, because I'd have to change all 4 of these every single time. So instead, we're going to use what's called a variable. Go to this Variables tab over here. For now, just think of a variable as a name. In this case, we want to use a variable that controls how fast Dot moves, so we'll just create a new variable called speed. Then, instead of using 10 and -10, we can just put speed for the 10s, and then go to operators and get this minus block, because since we need -10, we can just use 0 minus speed. Zeros. Go back to variables and grab another speed. Whoops. Where'd it go? There it is. Okay. Alright, so why is it called a variable? Well, the word variable just means changeable. We can try out different speeds much more easily now just by changing our speed variable instead of changing it in all 4 places. We can use the set my variable, change this to speed, so set speed to, let's say, 2 instead of 10. Let's test this out. That's a little too slow. So let's do 5, which is easier to change because we just need to change it in one place up here. That seems a little bit better. Okay, now we're just about done with Dot. Let's move on to the Scratch Cat. For the cat, we basically just want to keep moving around randomly and bounce on the walls. We can also use what we learned last time to make it change size and color just for fun. In code, the idea is, if Dot has caught us, then teleport somewhere else and keep moving around randomly. Otherwise, Dot is still chasing after us, so we'll just keep moving in the same direction. As usual, go to Events, and grab the When Green Flag is Clicked block. As you may have guessed, we'll be using another forever and if statement block to keep checking if Dot has caught us, but this time we'll use the if-then-else block. This block works the same as a regular if-then statement, where it checks if something is true and then runs the code inside if it's true, but if that something isn't true, we'll run the code inside the else portion. In English, this would be something like, if it's raining, bring an umbrella. Else, or otherwise, it's probably sunny, so bring sunscreen instead. Okay, let's make a variable for the score just like we did for speed. This is another reason why variables are helpful. We can use them to store things like numbers, words, whatever we want, and use these later wherever we want to. When the game first starts, we want to set the score to 0. We can also choose to show or hide our variables on the stage. We want the player to be able to see their score, but they probably don't care about Dot's speed, so we can just hide that using the checkbox over here. There are also different types of readouts if you right-click over here. So we're using the normal one, there's also large, and there's even a slider where the user can change it to whatever they want to. But we don't want them to be able to change their score, so we'll just use the normal one, and I'll just put it up here in the corner. Okay, now to check if Dot caught us, we'll use a sensing block called touching. And we'll put this in here. If we change this to Dot, then this will tell us if Dot and the Scratch Cat are touching. If Dot caught us, then first we'll increase the score by 1. Then we also want to go to a random position and then turn to a random direction. Those are both in motion, so we'll use go to random position and turn, and since we want a random number, we'll go to operators and use pick random. Let's say 1 to 360. There's nothing for actually moving here though, because this is just when we're touching Dot, which means that Dot has already caught us. We'll actually put the moving in the else portion, because we want the cat to keep moving when it hasn't been caught by Dot. The move steps block in motion we'll just keep moving in the same direction that we're facing. Let's move 3 steps because 10 might be a little bit too much. We also want to bounce when we hit the edges of the stage so that it doesn't go off the screen, and Scratch has that very conveniently as if on edge bounce. So that'll go after the move in the else. Okay, let's try this out. And if we touch, yep, and he also bounces. Great. Just for fun, let's also change the Scratch Cat's size and color when it's caught by Dot. Do you remember how to do that from the last video? We'll go to Looks, and we'll use Set Size, and we'll use Change Color Effect. For the size, we also want this to be random. So let's say super small, 25, kind of big, maybe 75%. And let's test this out again. Yep, looks like that's working. Okay, finally, just like we did for the letters, I'll add some blocks at the beginning that will set the cat's position, direction, and size so that it'll reset when we click the green flag. So for motion, we can just go to, let's say, the middle of the screen. For direction, we'll just point 90, which is to the right. And then for looks, we'll just set the size to 100, which is normal. We also want to do this for Dot to make sure that they aren't touching each other at the beginning of the game, because otherwise the score would already increase when you haven't even done anything yet. So we'll just make sure that Dot starts, this position seems pretty good, so let's just say, let's go there. Okay, let's test everything out now. Looks like it bounces. Oh, that's really small. Our score is increasing correctly. We can move in all of the directions. It's changing color. Yeah, looks great. So this is only the second lesson, and we were already able to create almost a full game, which shows you that variables, if statements, and loops are really important. We used variables to store information like the score, or just to be more convenient when the same thing shows up many times, like for the speed. We also used if statements to check when certain things happen. Finally, we used a forever block to make everything inside it loop or run over and over again forever. There are other control blocks you can use, like wait until or repeat until, which do exactly what they sound like. You can also use both types of if blocks, the if then and if then else, to make more complicated games that actually have an ending. So here's my challenge for you. Use this simple game that we've created and add an ending to the game using these new blocks that we've learned about. Maybe there's a timer that counts down and the goal is to get the highest score within 10 seconds, or maybe there's a stopwatch and the goal is to catch the cat 10 times as fast as possible. There are other fun add-ons too. Maybe you could make this a 2-player game, where one player uses the arrow keys and other uses the WASD keys. Could you make Dot and the Scratch Cat actually look like they're running using costumes that move their legs? What about playing sounds when Dot catches the cat? If you have pets, you could even take pictures of them to use as sprites instead of Dot and the Scratch Cat, or you could draw your own creatures. Just like last time, we have a studio on Scratch that I'll link in the description, and we'd love to see your games. Thank you guys for watching, and have fun!